Sherry Darby was lucky. On Friday, she was looking out from the Fort Morgan Peninsula and saw an interesting contrast in water in the Gulf of Mexico. It turns out that's something that's commonly called a tide line. And when you look at it from a high-resolution satellite from last Thursday to Friday to Saturday, you see sediment coming out of Mobile Bay, which is mostly fresh water, mixing with the salty water. And it turns out that fresh water is less dense than salty water, so you get this little sharp edge of sediment that floats on top of the regular water. And again, the nickname for that is tide line. It's all about a difference in density. I've actually seen that in the sky. This is video I shot a couple of years ago, and those middle level clouds are doing the same thing. It's a difference in density that causes that really sharp line, going from the upper 70s into the naughty 90s by lunchtime, and late afternoon, just a handful of thunderstorms, which is what we saw today. But the one that happened just before sunset in George County, that one was dramatic. A lot of people noticed it, like Jason Downey. He was out on the water looking toward the northwest, and you see that cloud growing tall and then spreading out at the top. Thunderstorms do that a lot, but today was a little different because there was very little wind shear and very little wind at the top of the cloud. So in other words, once it grew sort of like a nuclear bomb, it went straight up like a mushroom and then spread out once it ran out of energy, and then it had a shadow right around the top. So it looked sort of like a spaceship. That's a picture from the Eastern Shore. This one from Sharon Wilson, the same story from Foley, about 60 miles away. You couldn't see the bottom, but you could see the top. So what exactly was that? It was a thunderstorm cloud, and this was the satellite before sunset. There was only one thunderstorm in the NBC 15 area, and as the sun got lower, you can see the top growing and expanding, just like when you're walking through your yards looking at the mushrooms. Well, that's what thunderstorms do. Normally they bubble upward, but usually as they get taller, wind shear will start to tear them apart, or they'll lean over, they'll stop growing at some point. But what we had today was one where the air was so still around it that once it got way up high, it just spread out and created what we call an anvil, just like the anvil that a blacksmith uses. And there's another picture from Baldwin County from Christine Hipsch. There was another interesting cloud today, the Marge Simpson cloud. Did you see that one? There's Marge, she's looking that way. There's her hair up in the distance. Always something fun to see in the sky. Thanks to the internet, everyone has now heard Fujiwara. Well, what is it? The Fujiwara effect is a principle that when you have two spinning objects, whether they're hurricanes or even spinning tops, when they get close to each other, they start to pivot around each other. And look at this satellite view from 3 years ago in the Pacific Ocean. Two hurricanes came close to each other, and then they pivoted around each other. Watch it one more time and notice the distance between them. Both of those could have fit in the Gulf of Mexico. Hurricane Hillary, Hurricane Irwin, pretty strong. They got close together and then they started pivoting around each other. That is the Fujiwara effect, named after Dr. Fujiwara. He wrote this paper 100 years ago, a century ago. It's called The Natural Tendency Towards Symmetry of Motion and Its Application as a Principle in Meteorology. Read that and you'll understand more. The forecast winds are likely to maintain tropical storm force, and of course you see that cone ending in the Gulf of Mexico, but remember what the cone is. It's actually a bunch of forecast circles 24 hours apart that show you where the center of the storm is projected to be, plus you add the error, the possible error. Something else notable here, and that is these circles are pretty far apart at first, and then they kind of get squeezed together. The reason why, it's going to slow down once it gets closer to the Bahamas. So we'll watch it very carefully. Right now it's not an immediate threat to our region, but remember the forecast error, that circle that makes the cone, it gets really big. These are the radii or radius of each circle, 45-mile radius, 24 hours in advance. 5 days in advance, 225-mile radius. That means a diameter of 450 miles. And think of it like playing basketball. If you like to do a little free throw, well, go to the foul line, take a shot. You'll be lucky, you might get it in. Go back to the three-point line, you might get close, but once you get to half court, farther away, the farther you are, the more likely you're going to miss that target. And if you average out all of your shots, you're going to come up with the circle, and that's the circle that makes the forecast cone. So 5 days out, it's like being at the other free throw line trying to figure out where that system is going to go. This morning was quiet until 12 minutes after 10 when some of you felt a little shake all throughout the NBC 15 area, especially in West Mobile. That's video from Russell Hoover security camera. It was not an earthquake. These are the earthquakes reported and logged by the U.S. Geological Survey in the last day and a half. It felt like one, but it wasn't one. So what else could it be on the Gulf Coast? My guess, and I can't confirm it, my guess is a sonic boom. An airplane flies really fast, creates a pressure wave in front of it, and it creates a sound wave that we hear as a sonic boom. Keep in mind, sound travels about 760 miles an hour, but it's slower in colder air. Up there, it is colder, but sound can bounce, it could bend, it could turn, and you take an aircraft, and remember, we have lots of military installations across our coastline. In front of it, the pressure wave builds up, the sound builds up, but then the sound trails behind it, but when it passes you, it passes all at once, and that's that rumble and the shake that you get. And literally, it's a wave of pressure, just like pressure from wind, and in some cases it kind of creates a little wind for your home. But it all depends on how the plane is flying and how many planes are flying, and literally if a plane does that, if it banks, it can focus that sound wave in one spot and last longer than you might expect. So I'm guessing it's a sonic boom. The Air Force, Marines, Coast Guard, they never tell us, in part because sometimes they don't know what goes on up there. It doesn't always reach the ground.